Hey everyone, it's Ben from Board to Bits, and welcome to part 8 of our series on making a custom character controller in Unity. So now we can really get into the meat of our character controller and start controlling the movement of our character. In this video, we're going to focus on the walking movement using our walking controller. So we're really going to focus on 3 scripts today. We've got the input manager that we're going to be making some modifications to, as well as our controller, which is our kind of our template controller script, as well as our walking controller, which is the more specific controller that we're using for when our character is walking around the world. So let's jump over to MonoDevelop and see what we're going to do with these 3 scripts. So let's start in the controller script. And in this class, we're going to make a few modifications here. First thing I want to do is I want to make this an abstract class by adding abstract right here. So let me zoom in my text a little bit so you can see what I'm doing. And what this basically says is that no object in our world is ever just going to have a controller on it. It's going to have something specific, a walking controller, a flight controller, a vehicle controller. So that just makes sure that we're never just adding a plain controller. Now, we talked about in the last video that we're going to be using rigid bodies to control our characters, and so we want to make sure that we actually have a rigid body attached to a controller. How we do that is we're going to put in an attribute here, and we're going to say require component, then I'm going to say type of rigid body. Close that all off. Now, in addition to this, we're also going to want there to be a collider of some sort, because rigid bodies, they will technically work without a collider, but they're just going to be affected by things like gravity, and they're not going to actually do collisions. So it's not super helpful to have a rigid body without a collider. So I am going to add another one of these attributes and say require component type of collider. Now, it's worth noting, if you normally, when you have a require component attribute, if you add that component, like so if I were to add a controller component to an object, it would automatically add a rigid body for me. This one would work fine. However, because we're not specifying what type of collider needs to be added, it's actually going to throw us an error and say, you know, you need to add a box collider or a capsule collider, some kind of collider to this object before you can add a controller to it, which is kind of an extra step, but because we don't know exactly what type of collider we're going to have necessarily, I'm going to keep it as just type of collider here. So we left this note for ourselves a few videos back saying that we need to add a method to read the input that we're sending. So I'm going to do that here. We're going to say, we're going to create a public abstract class, or function rather. And it's going to return void, and I'm just going to call this read input, and it's going to take the parameter of an input data struct called data. Now, because this is an abstract method or function, because the way that read input is going to work is going to be very different from the walking controller as it is from the flight controller or from the vehicle controller. So there's really no point in creating any kind of a base functionality to this. So I'm just going to make this abstract, and then that kind of creates this sort of a contract with anything inheriting from it saying, hey, you're going to have to override this and make some kind of a method that uses an input data and does something with it. Now, it is worth noting when you make an abstract method like this, you don't put the brackets that you normally would. You don't even put them there and leave them empty. You just put a semicolon as if you're almost creating a variable instead. Unity will actually throw an error if you try to put the brackets in. It'll say that you can't declare a body of an abstract function. And that's what that means, is basically you can't set up anything in there, and so you can't set up the brackets to be even there in the first place. In addition to that, I'm going to create a couple of variables here. As we see, we have this rigid body here, so we might as well have some way to reference it pretty easily. So I'm going to create a protected rigid body, and I'm going to just call it RB for short. And protected basically means that anything that inherits from controller will be able to access it, but otherwise it basically acts like a private variable. And then I'm going to create an awake function here. And what all this is going to do is say RB equals get component rigid body. So that's just going to make sure that when we start our game, we have access to the Rigidbody component via this variable. One last thing I want to add to our controller template class is another protected variable. This is going to be a Boolean, and I'm just going to call this new input. And the reason for this is to kind of track when we stop hitting the keyboard. And that's just going to be important because we're going to eventually, if we're walking forward and we suddenly release the keyboard, the way we have our input manager working is that we're not actually going to send a message saying, oh, we stopped hitting the keyboard, so this bool is going to kind of keep track of that for us. So that's all we need to do to our controller script. Oh, and I need to add void in front of awake so that it actually has a return type. Otherwise, that function would not have worked well. Okay, make sure you have that in there, and now we can move over back, take kind of a step back to our input manager, because our input manager is actually where we're going to be passing the input from. When we get the input from our keyboard tracker, this is then going to be responsible for passing it to the controller. So how we're going to do that right now, we're going to create a public controller variable. I'm just going to call this controller. And so what this means is that anything that inherits from controller can be put into this variable. So that's how we're going to be able to put our walking controller into it. And I'm just going to keep it a public controller that we can drag and drop into right now. We'll do something a little bit more elegant and a little bit more sophisticated when we switch over to having multiple controllers and when the input manager needs to decide which controller is going to be getting this input data. But for right now, we'll just keep it as simple, work within the inspector, and put it in that way. And now once we have that controller, what we can do is when it gets past the input, we'll keep this logging to the console, kind of showing that our input is working. It's kind of a good way to check and make sure that's working properly. But then from there, we're going to say controller dot read input data. So really right now, the input manager is kind of acting as a middleman, getting past the input data from the keyboard tracker and then passing it to the controller. Eventually, we're going to give it a little bit more responsibility, but for now, that's what it's responsible for. So with all that in place, we can now jump over to our walking controller, which is really going to actually take that data, and instead of just, receiving the data and writing something to the console, it's actually going to move our character around. So how we're going to do that is we're going to create a public override, and this is going to be the override for that read input method that we had in controller. And when you type in override, what you should see is that read input appears in this list of options here. It's basically saying these are 4 things that I can override right now, and we're gonna override this read input, so we can either click or just hit enter, and that will automatically populate that for you. And you'll see what happens is it kind of pre-fills in the method here with this throwing an error, basically saying, oh, you haven't implemented this function. Well, that's what I'm going to do right now, so we can delete that. So the first thing we're going to do here is we know we're using our Rigidbody to move our character around, and how we're going to do that is we're going to set the Rigidbody's velocity. What that gives us the ability to do is say the moment we hit the keyboard, you're going to start moving at a certain speed, and the moment we release the keyboard, we're going to cut that speed completely and set it to 0 so that we have this really crisp kind of start and stop motion rather than kind of ramping up our speed and slowing down as we would with normal physics. What we need for that, though, is some kind of a data holder for what that velocity should be. And a Rigidbody tracks its velocity as a vector 3, so we're going to use a vector 3 to set the velocity as well. So I'm going to say vector 3, I'm going to say walk velocity. We're going to set that equal to vector 3.0. And now the first thing we're going to do is we're going to set vertical movement based on our input. And how we're going to do that is we're going to say if, and we're going to get the data that we're passed in. And remember, that data has a list of axes, or an array of axes and an array of buttons. And our first axis, our 0 index axis, is our vertical movement. So we're going to say if data.axes0 does not equal 0f. So if it's either positive or negative, but it's not in the default position, then what we're going to do is we're going to say walk velocity plus equals vector3 dot forward times data dot axes 0. This works particularly well right now because we know from our keyboard tracker, the way we set it up, that our axis is either going to be 1, 0, or -1. So we are taking this vector3 dot forward, which basically means moving a +1 on the z-axis, and we're either multiplying it by 1, so just keeping it forward, or -1, meaning it's going to move backward. Pretty simple. This would also actually work with a joystick, though, because if, say, we were just barely touching the joystick and it was at, say 0.1, then it would change this, from a full 1 forward to just a 0.1 forward, which makes sense too. So that's our vertical movement. Our horizontal movement is going to work pretty much the exact same way. So I'm going to copy this, paste it down here, and I'm going to say set horizontal movement. And instead of axis 0, we're going to look at axis 1 for both of these. And instead of vector3 dot forward, we're going to move vector3 dot right, because right is positive, left is negative on the x-axis for us. So we can save both of those. And the last thing we want to do here, you'll remember we put in that Boolean for a new input. Well, if we're calling this read input method, we know that we've received new input this frame, so we do want to make sure that's set to true. So we're going to say new input equals true. And the big reason for that is that new input being true is going to tell another function that we need to actually move our character this turn. What that new function is actually one that's built into Unity, but it's going to be very useful for us right now, and that is void late update. And there's two reasons that we're using late update for this function. The first one is that we're breaking it out away from we need to break this out away from read input, because we want to make sure that if there is no input, we're still responding to that and going to, make sure that we zero out our movement data. We don't want to just continue moving the last way we were moving, into eternity. We want to make sure that when we let go of a key on our keyboard, we stop moving. And so breaking this out into here is going to make sure that this late update will always be called, even if read input isn't called. The second reason, the reason we're using late update instead of update, is that the keyboard tracker actually is going to be getting the input information and starting this whole process in its update function. And then that's going to tell the input manager to do something, which then tells this controller to do something. But using late update is always called after all the updates are done. So when we use late update, we know that this is happening after all of our input data and our movement data has been set and good to go. Now we can actually move the character, knowing that that's all been processed properly. So in here, what we're going to want to do is we're going to say, first thing we're going to do is we're going to check and see is there a new input or not? If there's not a new input, then we just want to zero out our movement and proceed with that. Otherwise, we can keep whatever walk velocity we've set and then tell the character to move that way. So let's put all this into code. We're going to say if there is not a new input, then what we want to do is set walk velocity equal to vector3 dot 0. So if there is no input from the keyboard right now, just make this 0. We're not walking anywhere. You notice we have an issue here, though, because walk velocity is only exists within the read input function. So what we're actually going to do is we're going to pull that out of read input and make it a global variable for this class. So we're going to go up here and we're going to say vector3 walk velocity. And we don't need to set it because we're setting it both here and here. So we don't need to actually tell it what value it should be to start. The other nice thing about this is the way that this worked, the way I had originally written it, it was creating a new struct every single time every single frame that there's a button being pressed, which isn't the most inefficient thing in the world, but it's not great. This way now instead of creating a new struct every time, we're just resetting the value of it. It's a little bit better. So that's if there's no input, set that to 0. Otherwise, we can just keep it as whatever the walk velocity we set with these two axes here. Now what we can do is we can tell that rigid body that we're accessing because we're inheriting from controller, the RB rigid body here, we can tell that we want its velocity to be something specific. You'll see velocity lets us both get or set the velocity. We're going to set this equal to a new vector 3. We can't just set it to walk velocity for a reason I'm going to show you in just a second here. So we are going to use walk velocity.x for the x value. We're going to skip over the y value for a second, and we're going to use walk velocity.z for the z value. All pretty reasonable. But what do we want the y value to be? And this is a little bit tricky because we could set it just to the walk velocity.y, but that's always going to be 0. And we don't really want that because say we're falling and gravity is starting to pull us down. If we're setting walk velocity to, or we're setting our velocity to 0 on the y-axis, that's going to kind of reset gravity every single frame, and it's either going to, we're not going to move down at all, or we're going to move down very, very slowly, much slower than gravity would have us moving. So instead of using walk velocity, we're just going to use the rigid body's existing velocity on the y-axis. We're going to say rb.velocity.y, so nothing is actually going to change there for that. It's going to continue moving down, or if you're jumping, moving up at whatever rate you were moving, it's just going to change the walking, so your horizontal and your forward-backward movement are going to change. Last thing we need to do here is we need to say new input equals false. And this is so that, say, this frame we did press a button, we are changing the velocity based on whatever got set here. Now we need to make sure and set this back to false so that if we let go of the button in that next frame now, this will be false for us. Otherwise, it would always read as true, and we would never reset our walk velocity. So, with all of that done, we should be ready to jump back to our game here, hit our play button, and we should see, based on our input manager, which is for some mysterious reason in our scene. I'm going to pull that out of there. When we hit our W, S, D, and A keys, we should see that we move around our scene a bit. Let's hit play. And we are not, because we never set our controller. You'll notice here, null reference exception, and the reason that that is showing is because our input manager, we have our controller field here. We need to make sure we put our player, 2 steps back. We need to add our walking controller to here, and you'll notice we have our rigid body and our collider, so that all worked. We added that without any problems. Now we can drag that player onto the controller field. Now we hit play, and you'll see now if I hit A, I move to the left. If I hit D, I move to the right. W moves up, S moves down. I can even move multiple directions at once, getting kind of a diagonal, and I even hit that cube. Now you'll notice I'm kind of rotating as I hit the cube, and that's because we didn't lock down the Y rotation, which I might actually do, because for right now there's no real need for this to be kind of just rotating in this way. The other issue we're having here is that we're moving very slowly right now. Just the standard velocity of 1 per of 1 unit is, I think it's like a roughly 1 per second, and as you can see, it moves pretty slowly. So we're going to speed that up a little bit, and I am going to jump over to our player's rigid body, and I'm going to freeze the rotation on all of the axes. So we're not actually going to rotate when we hit the edge of a cube like that. Now to add some speed here, in our walking controller, I'm going to add a quick public float called walk speed. And I'm actually going to make that equal to about 3 to start. But we'll be able to adjust that as we want in our inspector because we're making it public. And then when we're setting our velocity, not only are we going to multiply by the axis value, we're going to also multiply that by walk speed. And we'll do that on both axes. Oops. So now, instead of just moving at 1 unit per second, we're going to be moving at 3, which will give us a little bit more pep in our step. There we go. That seems a little bit better. We could even up that a little more if we wanted to, but it's working. And as you can see now, we don't kind of rotate around objects. We just hit them and collide with them, and the movement's a little bit better that way. So that's our basic walking system. Works with our collisions and our physics. And that's kind of the basis of how we're going to do axis-based controls for our character controller. In our next video, we're going to get into making our character jump and looking at how buttons are going to react in our character controller. So thanks for watching, and I'll see you next time.